you felt like that, go ahead. We tried
Go ahead.
not
Yeah.
to make it a lecture,
Want those suggestions as well.
but
Yeah,
yeah,
we want those reviews.
Hello, very good evening to all my seniors, and I am Moksh Patak. First of all, my heartiest thank you for organizing this meet, and it has been very informative and insightful for, I guess, everyone present here, that is the freshers. So, I have
मक्खन
a
लगा रही हो
question which is somewhat not related to this, and but somewhat related to this, but like I am thinking about quantum computing. This is quite trending right now. IBM is working on it day and night. So I just want some insight into that field.
I
You
think
have the right
Abel here
person,
would be the
Abil
right
Bhaiya.
person.
Okay,
okay
I
Yeah, yeah.
believe you and Abel have.
Am I audible? Am I audible?
Oh, hi.
Yeah, yeah, you are
oh
Yes,
my
right.
god
Vedant.
You
wow.
are right.
Okay, Vedant. Vedant is first
Yeah,
then.
Abel Bhaiya, if you don't remember, I may tell you that he is the same guy
I know
who yeah, yeah.
okay so
क्या
adding on to
मैं
quantum
मेरा इतना
computing
मजाक
so
क्यों कर रहा है?
no, it's not about you. It's about he's just telling me that you are a pretty enthusiastic fresher who knows a lot, probably more than the seniors. So be careful before giving a false information to him because he may cross question you. So it is pretty true. It's good that we have freshers who are super enthusiastic about tech, super awesome. And I in my first year I did not know about the term quantum computing. The
Yeah,
only
Muril.
if I'm not wrong, there was a game by Microsoft or someone called Quantum Release or something, which was about I forgot the name.
No,
That was the
Quantum
only
Break.
time Quantum Break. Yeah,
Played it.
yeah,
Okay.
yeah. So Quantum Break. So that was I heard the name in a very NIT Oracle perspective. So adding on to quantum computing, pretty much like how Devabrat mentioned. So ऊपर से बहुत simple लगता है. Understanding how the things work under the hood is pretty difficult. So to understand that, it is pretty much like machine learning. If you're leveraging existing APIs, existing solutions, it's pretty easy. But if you're trying to build something out which is not out there, trying to modify the existing things, it is pretty difficult. You need to have a pretty good understanding of quantum mechanics in that. And if you're looking forward to quantum mechanics or machine learning, someone or anyone, machine learning or quantum mechanics, the first thing you need to do is get your concepts clear on linear algebra. Linear algebra, if you're new to linear algebra, you will be having a Maths 2 course, which you may or may not find interesting. But if you have interest in linear algebra, the best way to start is MIT OpenCourseware, Professor Gilbert L. Strang. Take that course. You will understand linear algebra. The world, it revolves on the very basic principle that the world around you is a matrix. Everything can be mapped as a matrix. Be it an image, be it a video, be it you as a person. Everything can be handled using a matrix. So if you're good with linear algebra, you can be a good in concepts of machine learning as well, concepts of quantum computing, quantum mechanics, and everything which involves core mathematics. So if you're into those fields which require core mathematics, get the basics cleared on linear algebra very first.
Clarifying, matrix is the mathematical matrix, not the film matrix.
Okay, thank you. I got it.
Yeah.
Thank you for your response. One more thing I gotta ask is that I have some info about quantum computers, and I know that to get the highest accuracy of quantum computers, these quantum computers need to operate at absolute zero temperature, that is 0 Kelvin or minus 273 degrees Celsius. So I don't see that coming it in reality as in near 10 years. So, do you think it is a viable career option if you go for quantum computing and if one has a knack for mathematics, especially linear algebra and whatever matrix and tensors
Okay.
and all that?
Okay. At no machine learning models we have as of now 100% efficiency. Does it mean that we are not doing machine learning? No. The whole point is that reducing the error ratio. So we have got quantum mechanical system. We have got cryo cooling setup which do pretty good job, which is pretty close to what is expected. If an error ratio of 0.1% is that, it's understandable. It's just a small thing which can be ignored. If you take it that way, machine learning is something which will never happen because we'll never achieve 100% machine learning efficiency. Same goes for quantum computing as well, and all the fields which involve mathematics to a large extent. And if you don't, so the people who don't know, we have got I think 118 elements in chemistry, and except hydrogen, no other element has a pure model. Everything is approximated with an error. So the entire world works on error approximation. It's fine. It's fine. Totally fine.
Actually, my question was not related to that error and all, but do you think that it is a viable career option in other 10 years and the future prospects in this subject?
I don't have a
have you-
3-year plan. You're asking me a 10-year future thing. I don't know. I'm the right
I
person to
like I
answer
don't
that.
yeah, I don't know. I just watched Big Bang Theory and those guys used to experiment on this
Actually,
stuff.
you don't need to worry
Me too,
about it.
me
Okay?
too. The string
Like 10
theory.
No,
years
I'm not
down the
worrying.
line.
It's just that it's an interesting field. Quantum mechanics, it really piqued my interest. So I was just
Yeah, yeah.
a bit
I got you.
enthusiastic about this.
But
Would
the
answer,
thing
but
is, you have to streamline it. Okay, like there is one software modality and hardware modality into it. Okay, if you are going to software modality, your knowledge will never go in vain. As well as if you are going into hardware modality of quantum computing, there also your knowledge will not go in vain. Okay, so if you are trying to learn it because it's a nascent stage, and obviously it will be developed. Looking at all the biggies are after it. Everyone is after quantum computing now, but yeah, you have to choose one. Okay, if you are going to look into hardware modality or the software modality, and then you choose your path, because whatever you learn to understand quantum computing is what is in use in today's life. Okay, we are pretty much using. Okay, learning linear algebra would help you in doing machine learning, and it's a basic course. Okay, in PhD, like in our college, as I know, PhD students are given this linear algebra course, and then they are being taught about the soft computing course in PhDs. So yeah, if you're taking linear algebra and learning it, or any kind of mathematical course to understand quantum computing, it will obviously help you in machine learning, and machine learning is now leading the way. So yeah, it won't go in vain. Okay, but you have to concentrate on one part. You don't have to think of what temperature the quantum computing work if you're into software modality. Otherwise, if you are into hardware modality, you don't have to think what the engineer has to code and how it will work.
Uh, Thank you, Bhaiya. Actually, my point was that I was just giving an analogy that does it have a good future? In what is your point of view about it having a good future and all? So I'm sorry for being a pain, but
Yeah,
thank you for clearing my doubts.
to be very frank, if I'll give a very quick example. How many of you do you think in the world know the languages like COBOL or C, COBOL or Fortran? They are pretty old languages, but still, let me tell you, still there are companies out there. If you are pretty good in COBOL or Fortran, you will get paid in millions. You ask me why? Because there are legacy softwares, governments and banks using those softwares. Irrespective of the technology you are, be it the latest cutting edge of the future or be it of the past, if you're good at something too good, there are opportunities out there which you can leverage. So if people out there who are doing COBOL and Fortran are getting paid in millions, because no one actually knows COBOL and Fortran as of now. There are physics department labs which use Fortran, which need Fortran developers. And the other side, you take quantum computing. So if you're good at any field, irrespective of the name and domain, you will land yourself a good enough opportunity and you will excel in that.
Thank you for your kind words and advice, Bhaiya.
Am I audible?
Yeah.
So sorry, but just stretching upon what Abel Bhaiya told, a little piece of advice for me, for especially freshers. The thing I also got confused in the first year was that there are too many fields. So just to spark the interest, we get attracted to each one of them, and then in the end, we do not pursue anything to the level of expertise. So while the curiosity thing is very nice, but what I should suggest is that pick anything you like, and if after exploring at the initial stage, choose one thing and at least learn it to the level of expertise rather than knowing too many things.
Vedant Raghuvanshi Bhaiya has aptly put down my situation in front of all of you. I'm just a confused boy who's exploring everything. Thank you, Bhaiya.
Actually, explore in first year, you could, but yeah, you have to be expert in one or other. Okay, you can't go in exploring throughout. So choose early. The early you choose, the better you know about a particular field.
The more time you have to get to know
Exactly.
it. So yeah.
Yeah, exactly.
Okay, thank you.
Anything else or we wind up?
Yeah, it's dinner time for everyone, I think. It's pretty much.
Yeah.